Okay, in this video, I'm going to show you how to compute the eigenvalues of a square matrix. I'm going to do a 2 by 2 matrix right here since that's the easiest thing, easiest size matrix to find this for. So remember that an eigenvalue usually is it's a constant. It's usually denoted in textbooks using a lowercase lambda. So an eigenvalue lambda satisfies the determinant of a minus lambda I equals 0. All right. In the notes we talked about how it's an eigenvalue is a constant lambda where a times some vector x equals the same thing as the scalar multiple lambda times x. But we've also seen that this is an equivalent way to solve that. And so remember that a minus lambda I is going to be the matrix A minus lambda times the identity. Remember that the identity has ones along the main diagonal and zeros elsewhere. And then that's the same thing as this. And then finally, when we actually subtract those, we will get 3 minus lambda and negative 1 minus lambda on the main diagonal. And then 8 and 0 are still here on this other diagonal. So basically what you can do is you can think of a minus lambda I as the same matrix if you were to start with a and subtract lambda off of the main diagonal entries. And so to find these eigenvalues, we would say 0 equals the determinant of this. And then we can just use the diagonal method here and say that that's 3 minus lambda times negative 1 minus lambda minus 8 times 0. And of course, 8 times 0 is 0, so we are just going to have 0 equals 3 minus lambda times negative 1 minus lambda. So lambda could be 3, or lambda could be negative 1. And in general, when you have an n by n square matrix, the only, or you can have at most n different eigenvalues. So on this 2 by 2 matrix, the most number of eigenvalues I can have is a 2. The reason why, if you look right here, I'm going to end up with a quadratic equation right here. It just happens to already be factored in this example, but with a quadratic polynomial, that's what tells me that there will be at most 2 different solutions. So I hope that makes sense. And in the next video, I'm going to show you how to do or find eigenvalues for a 3 by 3 matrix.